language, we will start today here the word that is called hardware description language. So practically there are two types of HDL are broadly classified. One is your VHDL and second one is your Verilog. Okay. So at what the HDL is comes here that HDL is the hardware description language. Here we have the a language which will describe the hardware of the circuit. Okay, that is your HDL. Now, how it will different from the software nowadays, which we have, if you might be explore that, like C or Python language can also use to describe the hardware that can be used for the VLSI design. So here, one provision comes here, the word that is called during the process or during the design flow, we have talked about the word called simulation and synthesis. There are two specific terms. Synthesis simulation, that is the process of verification, and it will only verify circuit correct or not. But when we talk about the synthesis, that is the additional feature compared to software language. Okay. So synthesis, it will generate the netlist diagram, and from where we are able to make the hardware that is called GDS2 file. Okay. So here HDL wins over the software language due to the synthesizer option or synthesis are available to us. But in the software language, we need to have directly synthesis is not possible. We need to convert into some specific format. Okay. So here, let's see some introduction about the Verilog language. So Verilog, that is it started in 1983, and it is used to describe the RTL of the digital circuit. Okay, where RTL stands for resistor transfer level. Okay, this is resistor transfer level. So now, Verilog or HDL language, it begins with IEEE number 1364, and it is used for the either ASIC based design or FPGA based design. Okay. ASIC, which ASIC stands for Application Specific Integrated Circuit. Okay. Application Specific Integrated Circuit, where FPGA stands for Field Programmable Gate Array. Okay. Now there are two types of specific hardware I'm going to take. One is your ASIC. Practically all the commercial IC are ASIC. Okay, wherever all the IC which is made up by the very complex process which we have already seen. So where we have to write the code, simulate synthesis, generate GDS file. This GDS file we have to send for fabrication, and they will kind of map into the hardware. This complete process is an output we will get IC which is ASIC, application specific IC. In contrast, FPGA, Field Programmable Gate Array, it is a pre-assembled board like Arduino. We have a pre-assembled board in which we have the processor, sensors, memory, switch, LEDs, display. Different type of component are already interfaced. We need to write the program, generate a .bit file. That is called bit stream file. We are using the word. Generate .bit file, upload into the flash memory of processor. It can work as a actual system. So here we don't have to rely on third party to develop the hardware. Only thing is we have our program software, we can generate bit file, download into the hardware, and it can work as an independent system. So here advantage is we require lesser time. Okay, we require lesser time. But in the ASIC, it will take the very longer time, at least 6 to 7 months to generate one output. ASIC. So this is the ASIC, what is FPGA? But there is a very nice difference arises here that ASIC, that is your ASIC, that is your static IC. Once we have fabricated, after that, not possible to change. It will remain the same. But in FPGA, we have to only change the program, change the .bit file, and our system can work according to the new program. So this changing the oriented architecture or configuration, that is called reconfigurability or reconfiguration feature. Because of this reconfiguration feature, FPGA we can use for the prototyping, what is called prototyping or testing of some new concept. But ASIC find their role into the commercial IC. Whatever the IC you are watching, either a mobile phone or television, switches, inductions, wherever or electric vehicle, wherever you are watching the IC, all are the ASIC based IC. Practically, there are 95% IC which are the ASIC based. Only for research purpose or prototyping, the testing, we're going to use here the FPGA. It is a pre-assembled board. No, it's not a single IC. Okay. So either we can go for ASIC based development or FPGA based development. In both the case, we need to use some language. Because here in the screen I have shown one is called VHDL and second one is your Verilog. Okay. So VHDL actually it stands for very longer word. Okay. So VHDL that stands for VHSIC. Okay, not a single word VHDL only. It is a VHSIC where it is known as very high speed integrated circuit. It's very high speed integrated circuit hardware description language. Okay. That is your VHSIC. Okay, Verilog, it is a complete word. There is no abbreviation for it. So it is called VHSIC and that is your Verilog. So it is a VHSIC. So HSIC are the silent. So it is known as the afterwards HDL. So very high speed integrated circuit. And after that HDL. HDL is hardware description language. Okay. So there are some specific differences like the VHDL is the library and package. We require the library as a package, but in the Verilog, there is no library, no package. It is the VHDL is a case sensitive language, but case insensitive, but here Verilog is a case sensitive language. Verilog is similar to the C, and because of this similarity about the C, it have got more popular. But Verilog VHDL was based on the ADA. It is a very older language. Generally, we are using the Fortran programming in the era of 1970. Okay. 70 or 80, then ADA was used as a language for formula translation. Okay, so now we have the difference between IEEE numbers, so that used for the either we can go for VHDL and Verilog. It is the interest of the user. Practically, both can be used. Okay, so now you have got some idea about what we are going to talk here, the digital design. And to have the digital design, to learn about digital design, we need to have one language. So either we should go for VHDL or we should go for Verilog. There's the one thing, one experience I'd like to share with you, like if talking about the industry or the interest of the student as well as interest of the industry. If I'm not wrong, 75 to 80% are preferred for digital design flow. In contrast, analog design flow or the CMOS design flow, there are more complex challenge. So here, very only specific set of people or the interested in our people preferred for the CMOS based design. Okay, so here maximum requirement or maximum amount of talents which preferred with digital design flow because of the programming features. Here we can do the program and we can generate it, or we can do the execution. In the CMOS based design flow, we do have the support of one programming language which is known as TCL, Tool Command Language. So TCL script is used for the design flow to make certain process, repetitive process can be simplified. Okay, okay, back to content here. In this slide, here I have shown the design flow, which is the one steps. What are the step-by-step execution for the design for digital design flow? Okay, so start with design specs that we have seen in our first session itself. Design specs, then description. In the behavioral description, we need to write the algorithms, or we need to define how the behavior will work, circuit is going to operate. RTL description, that I'm writing the word HDL. Here we need to write the programming language, whether VHDL or Verilog. Afterwards, it's coming the word formal verification and testing. This is a process of simulation. Okay, this is a process of here simulation. So here we're going to simulate by means of test bench. We will write the program main circuit program, which is a main module. Afterwards, test bench program to provide the input into the circuit, which is your functional verification. Afterwards, next step coming here, the goal synthesis. Okay. During the synthesis, we are able to convert into gate level netlist. Okay. So what I want to what gate level netlist. So all the component or all the structure must be mapped into the equivalent hardware, and those hardware are made up of logic gate. So it is necessary that all algorithms, all uh, tasks, or everything should reflected into the hardware separately, so that it will give the assurance that yes, their physical design can be possible. But there we will see in the future, like there are certain steps for which hardware is undefined. Okay. Like example, you call modulus operator, exponential function. Okay. So for these are the certain components, certain operators for which hardware is not defined directly. So we have to use some another approach, which is known as lookup table, LUT approach to design the equivalent hardware. Okay. So that it is called simulation. Then synthesis. The synthesis, we assuring that all the program, whatever we have used in the operator or in the word keyword, it must be have equivalent hardware. After that, again, do the simulation, which is your call logical verification. That is functional verification or logical verification with netlisted circuit. If there are certain bugs or some unsatisfactory result, again, we need to correct on this step only. That is your changing the program. Once we satisfied, yes, our logically is correct, then we can go for a step that is for floor planning. Floor planning, placement, routing, mapping. These are the certain steps, or we can go for physical design. So either we can go for ASIC or FPGA. Up to here, we have to repeat the process. After that, these are the steps. Either we can go for planning mapping, or we can go for from here PD flow. That is one word is called PD. In the ASIC world, it is known as physical design. Okay. Physical design, we are going to design the actual hardware in the term of material, silicon, polysilicon, uh, uh, interconnects, all things to be connected. After that, generate physical layout, generate GDSI file, and these are the steps we have to go to follow. But here our interest is to learn this language, HDL, how to learn this hardware description language. That is the interest for today. So, can you have certain input from? Can I have some input from your side? Whether you practiced this language, or should we start from the basics? message it. Okay. So can I assume it is your first time experience with the Verilog language, so that I should start from the beginner level? Yes, very good. Okay, so now this is because Verilog is a very interesting language, and it has a very huge, or it is having the requirement into the industry. So we try to learn this language nicely. So here, Verilog. So Verilog, it is one of the language which we have talked, which will describe the hardware. Now, as a methodology, I'm defining two different methodology. One is top to bottom, or we can go for bottom to top. Top to bottom means like we have one complex circuit, we will divide into different sub block, and every block again divided into sub block, again divided into the leaf cell, where leaf cell is logic gate. Again comes here the word logic gate, which cannot divide further. It is a basic brick of the digital circuit. So either we can think about this type of designing. One is your called top level designing, wherever one complex circuit are divided into different smaller blocks, and every smaller block designing with logic gate. So we are moving from top to bottom, so top to bottom methodology, or we can have the opposite case, bottom to top methodology. Like first of all, with the help of logic gate, we will make the micro cell or a smaller block, again join the smaller block to make the top block. Top block is my primary circuit, which our objective. So here data will move from leaf cell to top cell. That is your call top to bottom or bottom to top. But typically, we cannot say which is the best design. It's your interest. Whether sometimes you may follow the top to bottom, or sometimes you follow bottom to top, or sometimes you can mix together. It's completely user choice. Okay, that is your call design methodology. Here I'm going to use the very first letter module. Okay, like in your C language, you know, which is defined as main, void, CPP, C++, or C out. Different type of keywords is there. So first letter or every basic building block is a module. Verilog is called module. So we can start with the word called module, and we can finish with in module. Okay. This is the format for defining the any module or any circuit in the Verilog. Module space. Here we have to define some module name. Okay. After this module name, we have to define here the terminal. What are the terminal list? Terminal list are the name of input and output ports. That is primary input, primary output. Every statement must be ended with semicolon. These are the compulsory requirement. Module space, module name, again space. In the small braces, we have to write the name of port, semicolon. Here we have to define the terminals. Okay, in the center part, we have to define all the connections or all the program to be written here. And our program will end with one word we call end module. Okay, so this is a point which we have talked about. How can we use a program, Verilog language to write a program? Okay, so this is a snaps we are going to use module. So here module is the basic unit. Okay, basic unit of the program is your called module, and we can join multiple module to make the one sub module or top module. So word first letter is called module. Okay, so now how can we use the word module? So here I'm going to define, suppose I'm going to define this type of connection. So as a symbol, you can identify. Here this is my AND gate. Here we have going to define one OR gate. Here the input I'm defining the word A, here input is B, and here I'm defining the input is C. Okay. Here now as a output I'm defining Y. Now whenever it is asked to write the program for it, so we can start like it. Start the first letter is module. So remember Verilog is a case sensitive language, so it will ask do not mix here small letter, capital letter. The first letter of program will be module space. Here we have to provide module name. Module name are the user specific. Okay, suppose I'm going to write a name of module is temp. Okay. Some arbitrary name I have defined as a name temp space in the small braces define terminal. So here we have input A, comma, separated by comma B. Here we have C, and finally there is a Y. This is a Y. First statement, how to start with program. So module space, name of module in the small braces, write the primary input, primary output, then in with semicolon. Afterwards, here we have to define terminals. Terminals comes here input. Okay. So we have to define which is our input port, which are our output port. So we have to make it separation now. A, B, and C. There are three input ports. From the diagram, we can understand. So three input port A, B, and C, and we have a one single output port, that's the Y. So okay, here we have the output of Y. So for every program, first these three statements will be compulsory. Module name, list of input output, then input port, write all the name, output port, write all the name. Afterwards, here we have to define the program. Here we need to define the program, how the circuit are represented. Okay, how the circuit are represented with AND gate or gate. So after that, if you able to write the program, then every program with int with keyword is called int, okay, in the module. So that is the one of the structure how the Verilog program could be written. Module, input, output. Then in the center part, we have to write the program. Okay, and finally in the module. In the module is a single word. Now, how to write a program for that? Shall I move to next slide now? There are four type of abstraction level. The word is called level of abstraction or way of writing the program. Okay. There are four different methods through which we can write the program. First method I have defining into the like behavioral model, behavioral or algorithmic model. Okay. Second method is data flow model. Third method is a gate level model, and fourth one is switch level model. So there are four type of modeling style we are going to learn into the Verilog. That is your behavioral model, data flow, gate level, and switch level. And remember, these are the priority. I have written into the order of priority. First, top priority is the behavioral model. Second priority is the data flow. Third priority is the gate, and lowest priority is the switch level model. Now let's try to understand what are the difference between them. The behavioral model or algorithmic model, which are given the word highest level of the modeling style or level of abstraction. Here we are going to define behavior of the circuit or behavior of the hardware. Okay. So what meaning of it? Like the how a system or how a circuits are represented, so their behavior to be modeled. Like if I want to design one NAND gate, so their behavior will be according to truth table. For 0 0, it should be 1. For remaining, for 1 1, it should be 0. So how the if circuit are going to execute according to algorithms or according to the truth table, that should be defined as a behavior. Okay, that's called behavior modeling. These are known as the highest level of the modeling. Here we are going to use all the high level construct like your if else, switch case, then loop statements, task and functions. So we can use all the high level construct into the behavior modeling. The second number of the priority style is called data flow modeling. So data flow is here we are going to specify flow of data. How the data is going to flow between input and output. That represented by data flow modeling. So in the data flow modeling, there is a specific keyword I'm going to use assignment. Assign keyword. Okay. Assign keyword and the data flow, we have to use the operators. All the operators which you have learned in your C language applicable into the Verilog. All the operator and their meaning will remain same, symbol will also same. In the data flow modeling, we have to use assignment task, assignment and operator of the particular keywords. The third number is gate level modeling. So in this case, module are implemented in term of logic gate. Okay, then what I'm going to logic gate. So here we have to write the program and we need to specify which logic gate we have to use. Okay, so here all the hardware are defined by the design. Okay, fourth one is switch level modeling, which is the lowest level of the modeling style. And switch modeling is used as which designing a circuit using transistors. We will talk as a NMOS, PMOS, CMOS transistor level design instance to construct a circuit. Out of all the four, the most important modeling style is gate level modeling. Okay, most important is the gate level modeling. See the what is a Verilog is one is a language. So if we will develop or we can model a module into the Verilog language. After that, simulate it, verify the circuit. It's yes, my program is correct. It will do the semantic and syntax check. After that, synthesis. Synthesis is a process to assure we will get the netlist, gate level netlist. It means we are assured that we will get the hardware of the circuit. Now it is a task of software. The specific package is synthesizer. Okay, the one specific word is synthesizer, which converts a Verilog code or Verilog program into equivalent hardware. Okay, repeating it. So synthesizer is a one tool which maps or which convert Verilog program into the equivalent netlist hardware. Now, what hardware is logic gate? Now, it depends on the efficiency of synthesizer software, how much accurate conversion is possible. Okay, so it depends on efficiency of software. In the behavioral modeling and data flow modeling, the user do not going to define the hardware. They will only define the algorithms using some specific high level keyword like loop, switch case, break, even, join. So we can use this type of specific keyword at the higher level to make the circuit or design the circuit module. But their interest of user is not given into the hardware. It depends on the software-based conversion. Data flow modeling. Here we will use the word operator, assignment as operator. Now here as a language, Verilog, which will take the help of IEEE library and try to convert the operator and their equivalent hardware. But sometimes it comes a situation that hardware is not available. Okay. Like hardware is not available. Like you must be knowing in the digital design, here we have only adder block. We do not have subtractor. So we are performing subtraction by means of addition. That is called 2's complement. Multiplication, it is implemented via repetitive addition. Okay, so as a hardware, we are as a data flow modeling, we are not specifying, we are specifying the operator, but we do not know for every operator hardware is available or not. If sometimes hardware is not available into the IEEE library, it will generate a black box. Okay, we will get here the black box into the output, and this black box are not able to convert into actual hardware logic gate. So here interest of industry comes here that designer must should write program into the gate level modeling, because in this modeling only we assure we have the possible hardware. Hardware can be possible to fabricate because all hardware are defined. No doubt a difficult task. Very first, we need to develop the on the paper pencil. We need to draw the circuit. After that, start writing the program. But it guaranteed that yes, hardware can be generated. And switch modeling, that is the transistor-based modeling. So we will call NMOS, PMOS, CMOS from IEEE library, and it will make the connections according to the program. Okay, guys, so this was my introductory part. How can we use the modeling? Four type of modeling style we will follow in the data flow modeling, behavioral modeling, data flow, gate level, or switch level. Okay. I hope so you're comfortable up to here. Let me check if some message to me for us. No. Fine. Okay. So now, till now, what we have provided the introductory part of the Verilog and how can we use how Verilog can be used for writing the program. Now here I will not take the other content. I will try to convert or I will try to put you into certain programming language. How the Verilog language can be written. How the Verilog language can be written for the specific case. Okay, so let me minimize this part. Okay, so before proceeding, today I will just try to showcase here one program. How can we write a program? But in this slide, I have mentioned a very interesting figure here. 4 valued logic. So in the Verilog, it supports 4 valued logic. 4 valued means any keywords or any variable can be have any out of 4 any one of the possible value. That is the true, false, 0, 1, x, z. 0 and 1, that is your binary 0 and binary 1, true and false information. But x X is your unknown value, which is possibly you must have read about don't care condition. Okay, so X is represented as don't care, and Z that is represented as high impedance or tri-state condition. Okay, so here what I want to try to showcase here that so a very log variable can be possible any one of the value 0, 1, x or z. So 0 and 1 are the separate case. Z represent high impedance. So if sometimes you found we will found that there is neither 0 nor x. If suppose there is something called neither 0 nor x, that is represented as Z state. Sometimes we will found that there is 0 and 1, both are appearing together. Okay, 0 and 1, both is appearing together. That is known as a X condition, either 0 or 1. So in the program, I will try to show it to you. Uh, how can we, if sometimes a variable got two different value, either 0 or 1, that is known as a don't care condition X. But sometimes there is neither 0 nor 1, there is no possible value is there that represented as high impedance or Z state. Okay, so now here what I want to showcase here that suppose we want to write, I will tell you how can we write a program. Okay, I will start from the simple program. I'm going to start with the word one, like suppose AND gate. There is a one, another OR gate I have put. Okay. And here I have put the three input. Then namely, I'm going to use the word left side A, B. The third input I'm going to provide here C. Here we have the output name is Y. Okay. So when we are going now, in the very log, it is necessary that every logic we have two logic gate and or. I can define the name of this logic gate is A1 and name of this logic gate is O1. So we have to define some local name for every logic gate, even though not compulsory, but if you're defining it will be helpful for us. Now, these are it is necessary that every connections or every signal must have some name. Like we are defining the name of input, name of output. This central connection, there is no name has been defined. So it will declare as wire. Okay, that is represented one word that is called W. So here I am defining the word two AND gate, one OR gate, X, there's a one wire, and I'm defining the one output as a Y. Now here, how can I use or how can we write a program into the module? That part I would like to highlight over here. Okay. So for the first case, I have informed you earlier also, here I'm going to do the first letter or first word to write a program is module. Okay. Define the word module space. I'm writing the name temp, some module name. Now here one thing I want to highlight, name of module do not start with number or special character. Like first letter, I've written the word T, the first letter should be alphabet. After that, we can add the numerics. But module name never start with numbers or special character. So module name temp. Now here we have to define all the port. I'm defining the port name A, B, C, and Y in with semicolon. This is my first statement I have wrote. The second statement, which is We have to okay, A, B, C. Now, according to the circuit, what we have to define first, input. We have to write what are the input to us. Input are three input. I'm writing A, comma B, comma C, in with semicolon, and there is a single output. The name of output is Y. Okay, so here this is my area of interest. Here I have defined how the circuit has been mapped and how it can use for the programming. Very first module temp input output up to here it will remain same in all the four modeling style. After that we have to take our interest whether I want to go for data flow, gate level, switch level or behavior modeling. Okay. So here I have mentioned that gate level is a very interesting fact where we have to write the name of gate. So in our IEEE library, all the logic gates are predefined. So we can call the gate, like in C language or C++, you must have learned, we can call the function by their name, calling by function or calling by name. So same thing to be repeat here. We can call a logic gate from their name. It is defined AND or NAND NOR NOT XOR XNOR. These are defined from their name. Like I want to use one AND gate. We are write simply AND. One AND gate is a word. So AND is a keyword or reserved word for Verilog. So it is a system defines. So and the temporary name I have defined the AND A1, that is local name. Now here it is a one constraint is there. This AND gate is system defined or IEEE defined. So we have to follow their order of port. First we have to write output port followed by input port. In the user defined primitive or user defined module, we have the choice. Either we can write input, output, or in any order we can write. But when we want to use library defined logic gate, need to follow their order of port. So for AND gate, we have to write first output. Now what is output here? That we have to look into the circuit. For AND A1 output is W wire. So W comma input is A, then input is B, in with semicolon. So this AND gate we have mapped or we have programmed. Okay, this is simple way we have wrote the program of AND first AND gate. Okay, I took the dot here. Afterwards, we have to take the another gate. So for every gate we have to write separate or local name. I am defining the O1. Now here we have to define the first output of OR gate, then input of OR gate. Output is Y, input is W and C. So we have to look into the circuit and we need to write the program. Just do the port map. This process is called port mapping. So mapping of the input output port according to the circuit. After that, we are finding that we have only two logic gate and define a program, so nothing to do next. So we can go for int module. Okay. MODULE. Okay, this is a called int module. Okay, this is a one of the program how a Verilog code can be used for gate level modeling. Okay, so this is the one of the way how I'm going to I wrote the this is gate level model. I hope so you got some idea about from here what is the gate level modeling. So here we need to define name of logic gate which user want to use into the circuit. Okay. Now back to here. Another type of program. I will copy this code so that you can save our time. Okay, so in the other type of modeling style, so I'm going to use a word that is called data flow modeling. Okay, so I'm going to write the word. In this case, up to here it will be same. Only there is a modeling part will change. Okay, that is a data flow. Data flow modeling. So initial part remains same, module input output, only the programming will change. So here I have wrote the AND gate, but in the data flow, we need to do the assignment operator or assignment statement. Assignment statement is a statement which is initiate or which use the assign keyword. So I will use the one keyword assign, and it will compute the RHS output from LHS. LHS are the input variable and operators. Yes, you can make your definition. So assignment statement generate out or compute output from the input variable and operators. Because their focus of interest is operator. So here we will start with the word assign. This is a keyword I have to use. So when we write this code into the software, you will get color has been changed. This is a keyword. So assign. So we have to write for every logic gate separate. Okay. So first logic gate output is W. So we can write assign W equals A AND gate. What is the operator for AND? AND B. So this is a way of writing program in data flow model. Okay. So here I have wrote simple way assigned for every wiring, every output connection, we have to define the assign. Or we have for output assign, we can write y equals the operators, that is a or operator W semicolon. So this is the way on finally in module. Okay, so now you can have the difference between comparative difference between data flow or gate level. In the data flow, we have used operator. With the gate level, we have to write the name of logic gate. After the synthesis, I may get in the gate level modeling, I will get the gate level circuit, but data flow modeling, I am not sure whether I will get logic gate or not. It depends on synthesizer. Okay, how the synthesizer will convert into operator into hardware. Now, which logic gate they will use? They may use AND gate or they may use NAND gate, NOR gate, XOR gate. Finally, they will make the function. They will compute the function y equal to AB plus C. That is my equation. But which logic gate we have to use? That is not directly defined. Okay, that is the major difference between gate and data. Okay, so now in this case, third case is the behavioral modeling that is mostly used. So behavioral modeling, here we have to learn some specific keyword style, that is FL switch condition. So I will not start right now behavioral modeling. Okay, so basically we will start with parallelly both data flow as well as gate level. Okay. Okay, in the same way, but here one thing I want to do the how can we do the shortcuts? Like if I'm going to write the one same program, this program again, I will copy it. Now up to here, this is a data flow modeling. I want to highlight again. So either we can follow the one method, define every keyword separately, or we can combine together. Okay. Or we can merge two statements into single statement. But for that, we need to learn the priority order. or how to define the which logic gate will compute first. Look at the diagram. Here what I have defined our circuit is AB plus C. Okay, our circuit is make AB plus C. So AB is a one separate gate or is a separate gate. Suppose if I'm going to write the word assigned y equals, our equation is AB plus C. Okay. So first of all, we have to write A and B. That is my first level of the circuit. Now this A and B must be included into one parenthesis. This gives the one priority. First, we have to compute A and B. After that, I'm writing the word or C. Okay. So this is my complete statement. Both and or are combined together and make a single statement. What interest is here, this parenthesis, which gives which logic gate will compute first, A and B, then OR. Okay. So here we will practice this type of programming now, or our next session, how to use Verilog for the learn. Okay, guys. I hope so you got some comfort or an interest into here. Okay, guys. So now play back to us. This is something which we have started today. That is the major interest of the programming of Verilog, and here our focus is how to learn Verilog HDL, and we will try to do the experience with certain EDA tools. Now today, as the next session, here I'm going to discuss about how can we use some software, either offline software or online software, to design certain circuits. Okay. So now, if you have already worked with certain tool, the name of the tool which is mostly used here, one is your Cadence, which by default we have. By default, Cadence provide the tool for all the cases. So one of the name of the tool, I'm writing the word Cadence NC Sim. This software is used for the designing of the digital circuit. Cadence NC Sim, which is followed by one internal software, Genus, and another software we have after that. NC Sim is only for the programming in Verilog. It will do simulation. Genus, it will do elaboration as well as synthesis. Okay, here we are doing the synthesis. And after the synthesis, it will generate netlist file. And after that, physical design will start. The software we have to use the Innovus. Okay. Innovus is a tool that mostly used for the physical design, PD flow. Here we have to think about your complete physical layout, floor planning, placement, routing, mapping, and GDS file generation. That is for ASIC case. Okay. We have the another thing for ASIC. Now coming for FPGA part, the FPGA is a one very nice tool which I am founding is Vivado. Accessing of Cadence is somewhat difficult for all. It is because of the license part. But Vivado is one of the tool which can be accessible to all. It is a open source. I should say directly open source because they provide the evaluation software license for 1 year. Okay, for 1 year software. So we can you can download this tool Vivado, after but it is for FPGA version. In this case, we have the option of simulation, synthesis, implementation, and generation of bit file. For learning the Verilog program, this is one of the best tool which I have found, Vivado. I will show you how to download it, and there is a uh, third option. I'm going to write EDA Playground. Okay. EDA Playground, it is one of the cloud-based software, or it's a web-based tool where we have to simply create our profile via our login, and after that we can start with coding. We start with writing program EDA Playground. This is the one we have to use. Okay, so we have the option either we can go for Vivado part or we can go for the EDA Playground. So now if I'm going to showcase you here Vivado. Okay. Vivado is eventually one tool or not what we have defined the word. Not defined wire W. Okay, that's nice, correct. Now I have seen your message in this word. You are talking about the word. We have defined the word wire. But practically right now I am not provided the definition of wire, so I have not commented more into that. But practically we define a wire as a bidirectional. It's coming to us here. One thing I want to show here the word Vivado. Vivado is one of the tool where we can think about AMD. AMD actually it was the first was Jiling University XILINX. Now it has been taken over by the AMD. So AMD are providing using this Vivado design suite, and we can get the 1 year of the license from here. So they nowadays they have more advanced. Now Vivado are providing the FPGA for machine learning, data science, gaming application. They are making the FPGA for the latest version. Okay, so here we can go for the product. We have to find the download option from here. There is a product software. Okay. Vivado, sorry, research it again. We go for downloads. In the downloads, here you will find the we have the some latest version from 2025, 20. But when you're going for, but these are the not completely stable, so it is recommended to go from 23.1. When you're going for 23.1, here the size of the software is very high. It will come across 40 to 50 GB. Okay, it's going for 40 to 50 GB. So it will be difficult to download for you and require data constraint. So here I may suggest you go for some older version and try to prefer the 2019. It is coming, even though it's coming around 2001. Sorry, it's coming around 20 GB or 22 GB of the package. Okay, so here for learning, this Vivado can be to 19 version. It is sufficient. Here you can go for download this installer and follow the path. Afterward, it will redirect you and how it will redirect. How can we go for the designing the tools, like accepting the license and registration of your MAC address. Finally, they will send you one, and you have to create one account on the AMD profile so that your license will be given your email. Okay, there's one option in the Vivado. If you can download it, so you can get the offline access of the tool. Or alternate method is the EDA. This is one of the web-based tool we have, EDA Playground, which is the most stable case. But here we need to have high internet So it is an online tool, so internet, stable internet should be there. Let me refresh it again. So either we have the option, either we can go for the Vivado tool, which is offline, or we can go for the EDA Playground. So this is my planning for today. Like we have started with introductory part about HDL, that is the Verilog, and we will try to start or we'll try to write a program with Dataflow or gate level modeling. And we will try to introduce certain specific keyword from operators, their understanding, and how can we use how can we use that into the programming. This is one of the interface for EDA Playground. If you have practiced it, if you have the account, you can go for it or simply log in with Google. May use any one of the email account. Okay. So this is the interface where we can use to further very online Verilog simulation. Okay. So this is your EDA Playground. So here we have option. So they are providing two interface. One is your designing, where we have to write the program. Second one is your test bench. So here we have to write the test bench. Okay. Test bench is we will use for simulation purpose. In the left side, they're providing certain aspect, language we want to use. So they support different language, Spacman, Python, C++, Perl, so we go for Verilog or SV, system Verilog. UVM, OVM, that mostly used for verification purpose during the SV. Library, again, it is for system Verilog, right now, not our interest. Here we can go for enable of the TL Verilog, erasure UVMs, leave that part. Here we go for tool, which tool I want to use. So here they provided some simulator. Which simulator are used? So there are certain commercial simulators which are required certain license. Here free simulator, here we can go for the GA Verilog iCruise. So we prefer to use iCruise simulator for the simulation purpose. Okay. Now here we have the provision. We will go for EP wave. Here we can open EP wave after run. So after running a EP wave, it will generate the specific test bench. Okay. So this is one of the ways we can write a program. Now, if I'm going to take my code like this is the code I'm going to simply copy from our program, and I'm going to paste into this module. Okay. This is our way how can a module or how the EDA program can be used. Here we have option new, or here we have the run. Simply run it, and it will able to access. Okay. So they will give you the option like wall or design test bench is undefined. Here test bench is undefined, and so here we need to write the first test bench out. Okay, so when we meet tomorrow next time, we will discuss it how to write test bench of the specific module, and we will try to learn uh, with some programming in Verilog. Okay. So meanwhile, if you wish, you can explore this interface or PDA Playground, or if you have the more interest in the FPGA part, you can download this tool from Vivado HLS. So try to prefer for, if you have the interest on machine learning, then you can go for the 23 or 22 that support the ML version. Or if you want to go for only the digital learning of Verilog or digital part, try to prefer lower version, because when you're going for higher end, the software become bulky and it will take more time for simulation. Okay, guys. So with this, I think I'm going to stop by here, and when we meet next time by next session, so we will try to discuss. We will talk more about the Verilog programming. Okay. So if you have some queries, please go with that. Okay, guys, let me stop by here now. So we continue by next session, and we will try to more deeper on Verilog language. Okay, guys, so now let me stop by here session now. So meet by next time.